share my screen. Share screen. There we go. Okay. So let's just try to do it on different page. There we go. I'm just gonna add the photos that I just took from your thing.
Okay.
There we go. So this is the I think this is the direction. No, this is the problem, and these are my directions. Oh,
Great.
which are not being selected for some reason. There we go. Okay, so it says, please find the derivative of the indicated variables. Simplify the answer to match the given answer in the problem. Okay, so basically when it tells us to do this a certain variable, that means there might be multiple variables in the equation, and the rest of them, we just consider them as constants. You only want to look at what they want. So when they say dx dy, that really just means you're looking at the y. Oh, that's a big arrow. But that really means that you want to look at the y, okay?
Okay.
Yeah. So it says given x of y, find dx dy. Okay, so let's see. How are we gonna want to do this? So it says sine.
So we could do is we could put brackets
Mhm.
between sine and then y, and we'll do a second bracket where y is.
Exactly. So I can take the derivative of both of sides, right? So this is d dy of this part, and then actually let me just erase this one, and then we'll do d dy of y, right?
Why did we put that? The d and then dy.
Oh, that means I am taking the derivative of this side with respect to y, and of that side with respect to y.
So would that be the same as brackets or no?
I think it is. It's also notation. Oh, you guys are doing implicit, short and easy. Okay, you guys want to do implicit then?
Yes.
Okay, well, then, let's see. If it's implicit, then the way you solve it is you start taking the derivative with respect to y, right?
Right.
Okay, so let's start doing that. How would this turn out? What is the derivative of sine?
It would be cosine,
Uh-huh. And
and
then
then
the
the y would be just dx over dx
it's just
over dy.
one. Yeah, well, actually, for this one, it's just one because we know that we're okay. It didn't say find dx dy. I mean dy dx. Okay, so if it said find dy dx, right? Then that would be correct.
Right, but it's asking us
It
to find.
changes it with respect to x, but now we're doing dx dy.
Yeah, there's just some switch.
Yeah, so now when we're doing implicit differentiation, it's actually the x that's gonna give me the dx, the dy dx. Okay, here I'll show you how I'll show you what it means. Well, also this is not complete, right? Because we still need to take the derivative of the inside. So I know we had sine. Let's go back to the sine function. We had
Okay.
sine x in terms of y, obviously y is equal to y. Okay, so now I can take the derivative of this. It's gonna be cosine, right,
Right.
of x to the power of y of xy times y times this is gonna give me a product rule. Here, this is a product rule.
Okay.
So it's gonna be the derivative of xy, right, with respect to y.
Right.
But this is not gonna be very helpful for us. So what we do is we say is you're gonna have to do it when you do it. Basically, you're gonna have to do it with respect to x, and then keep the dy so that you end up with another dx dy. So basically, what I'm gonna do is I'm gonna just multiply this guy by dx over dx, right? Because this is basically just 1. And then dx over dx, like this is something, and then we're gonna end up with dx dy. Okay, I'll try to explain it a different way. Let's try to invert the problem. Let's try to do it as, okay, I have sine y.
So we could probably make it as x.
Yeah, so basically whenever you see an x, it becomes dy dx.
Oh, all right, yeah. Let's see. We're doing the opposite.
Because it used to be like sine x y equals y. Then if you just do this and you do it with dy dx, then you'll end up with cosine x y, right? Times times
right, yeah, dx
over dx, and then this will give me a product rule where it will be dx over dx times y plus x times dy over dx, right? This is just 1. This here is just 1, so it just becomes y plus x times dy dx. It's the same thing, except now we just flip the x and y. I know these ones are a little bit complicated, I'm not gonna lie. Here. We're gonna keep doing it. Let's just do it in a different way. Maybe then you'll see it better, I guess. Here, I'll just redo it, and then we'll see if that'll help in any way. So,
I think for this part, we should keep is cosine in parentheses is x, and then y, and then we'll do is the product rule on that one.
Yes, exactly. So this is a product rule. Exactly. Have you done like number 1 and 2?
Yes.
Yeah. See how here it tells you dy dx. Here, maybe let's. Okay. You got the answer for this one, right?
Right.
You got it correct. Correct. Like you did it right.
Yes, with the tutor's help.
Exactly. So that's perfect. It's good that you got it right, and it's gonna be the same thing, except now we just switched which variable we're differentiating by. Instead of differentiating by x, our change is now in y. Okay.
Okay. So now we will include. I mean, we could write it down now. Certain parts.
Yeah. So yeah, do you want to tell me how the product rule is gonna be? So this is your right. This is gonna be cosine xy, right? But then
right.
or x, sorry, small y, and then x small y times y.
And then
what's my product rule gonna give me?
So we're gonna replace so x would be it's just dx over dy.
Yeah, well, x, it's gonna be dx over dy, but that's not what we're looking for, correct? We're trying to, oh wait, actually we are looking for that, yeah, because I keep getting that mixed up too. Okay, yeah, you're good. So this is dx over dy times y, right? Because the y, because the y stays constant. This is like f of x, or actually g of x, you call it g of x, h of x. This is g of x, and this is h actually of y in this case, g of y and h of y. Okay, so when you're doing the derivative, it's gonna be g prime of y times h of y, because this is the product rule, right? Plus h prime of y, g of y.
Couldn't we change y to h?
Well, yeah, it is. The y is h of y. So basically, this is the state constant. So this is the state constant.
Oh no, I'm sorry. I meant we'll change H to F.
Oh, you can do that if you want. Yeah. Here. Okay.
Okay.
Yeah. So this stays constant, but now we have to add, right? Because we're not done. The product rule is this is G prime of Y, and this is F of Y, and now I need prime of Y. What is F prime? What is Y? With this, like if I take the derivative of Y with respect to Y, what is it?
So for what for G, right?
Yeah, we finished G. We did G of G prime and we did F of Y. Now we're looking at F prime of Y. So what is the derivative of Y with respect to Y?
It's just 1.
Exactly. Awesome. Perfect. Times, now just G of Y, we just keep it constant. So it's just times XY. Okay?
X times Y.
Oh, it's not X times Y, it's X of Y. It was that little like Y at the bottom.
Okay.
Yeah. So this is it. So now equals what they said it was equal to Y, right? So what is the derivative of Y with respect to Y?
It's just 1.
Exactly. So this is actually just 1. Cool. Let's rewrite it in a little bit more neat. So I know that cosine X of Y times Y. I think what gets like everybody confused is that like bracket, like X of Y, but whatever. But it's just telling you that here the X is dependent on Y and that Y is an independent variable. It doesn't really mean anything.
Okay.
So, oh, not plus, sorry. Times times dx over dy times y plus xy equals to 1. Okay, well, let's multiply let's multiply this cosine to this term and to that term, right?
Right. So it would be now.
So this would be yeah. What would it be? You tell me.
So it'll be x. No, we'll put dx.
Dx over dy.
Dy to x.
Times.
Times. It will be times just x squared.
Oh, it's not x squared. It's just this one, right? We're multiplying this term, this pink term here, by each one of them. So it's just going to be times cosine of x, y.
Right.
Times y, because this y right here, right? Becomes that.
Okay.
Okay, now plus this cosine, this xy stays the same. This one gets dropped here, xy times cosine x, y times y. Okay? Equals to 1, obviously. Okay, so where's my dx? It's right here, right? Oh, sorry. Do you see it? I just circled it.
Yes, I see where you circle it.
Yeah, and this is the only, this is what I'm looking for, right? That's all I'm looking for. I'm not looking for anything else. Right? So that means I can get rid of that portion and put it to the other side, right? How can I do that? How can I do that? Subtracting, exactly. So it's gonna be minus xy cosine of xy times y. And here I do the same. I subtract the same term, minus xy cosine xy times y. Perfect. So now I ended up with a really important thing. I ended up, let's keep the dy, dx, dy blue so that we can see it. Times cosine xy times y multiplied by another y because of that y right here is equal to 1 minus xy cosine xy times y. Right?
For this part. Switch the signs, okay? And then
Yeah. So now these are all multiplied together, right? This is multiplied by this is multiplied by that. How can I get rid of the pink so that I can get this blue term alone? Because that's all I'm looking for, really.
we'll just divide it.
Exactly. So I will divide by cosine x, y, y times y. And divide this term by the same thing. Cosine x of y, y times y. Okay, so now we found the answer. It's gonna be dx over dy is equal to 1 minus. Okay, well, before I finish writing this sentence, I want to remind you that these are meaningless for, like, they're not used in calculation. All they mean is that x, oh, sorry, all they mean is that x depends on y. Okay?
Okay.
So I can just get rid of them when I'm writing the solution. I don't really actually have to write them. It's just for me, it's just reference. So it's 1 minus x, oh, on y. It's just 1 minus x cosine xy over y times cosine xy. Now let's go back to the solution. So this is my final answer right here. Now let's go back to the question that they gave us. Oh, look at that. We got 1 minus x cosine xy over y cosine xy. And we got here 1 minus x cosine xy over y xy. Okay?
Okay.
Perfect. We got it.
Noor, can I take a picture?
Yeah. Feel free.
And I have some more questions. Can you zoom more, please?
Oh, yeah. You want to zoom like that?
Yeah. So we start at the beginning right here, where the distributing is.
Yes. The distributing here, you mean?
Right there. Yes.
Yes. So because when you distribute, okay, the dx dy, that guy right here, I'm kind of like, this guy right here, the yellow one,
Yes.
this one got transferred over here. Because you know when you're multiplying things and they're not the same, you can just leave them as multiplication because they're variables. They're all just like weird letters.
Okay.
Yeah. Yeah, so that's what, and then the cosine xy got multiplied to it. So this is where I got this guy. And then the y just got dropped.
Okay.
Yeah. And then same thing for the second one here, the cosine multiplied here. And so I ended up with the cosine and then the xy just dropped down.
Okay.
Yeah, and then equals to 1, and then I just used algebra to isolate it. So we subtracted, remember the subtraction? And then we divided. And then we divided by these terms right here to isolate dy. Because our whole point, like the whole point is to isolate this.
Okay. And then I have a question on the top part right there. In
Wait,
the
which one?
on the blue.
Yeah, this one, this part here.
Yes.
Okay.
So I'm still confused right here where it says when you put in parentheses. This is where I'm still lost.
Here?
Yes.
Okay. Here, I'll show you something before then. Let's think of it as, okay, I don't know, I have sine 8x. Can you give me the derivative of this?
Oh, it would just be as cosine of ax.
Oh, cosine 8x. Is that it?
Oh, it's just it's cosine 8.
No, it's cosine 8x times 8. Why? Do you remember why? It's something called the chain rule.
Right.
Right, so the chain rule tells me you take the derivative of the outside. So it's going to be d sine 8x, right, over dx, dx, multiplied by the derivative of the inside. So multiplied by d 8x over dx. So this portion right here gives me the cosine 8x. And this portion right here gives me the 8. So when I times them together, I end up with 8 cosine 8x.
So for this one, okay, so cosine. So that x is just right on top of the dx over. I mean, the word in the parentheses where ax, that replaces with d over dx.
Yeah, so it's dx, and then exactly. So like here, it's a little fancier version of that. So remember when it was the original problem told us we had sine. What was it? It was sine. Give me a second.
Sine and parentheses x.
Yeah, sine x x y, right? Yeah,
Yeah.
that was it. It was sine xy. Okay,
Equal
but
to y.
we're doing it in terms of y, right? So it's not d dx, it's dx dy.
Right.
Okay, good. Okay, then here, you're just bear with me because this is like a complicated one. It's not a complicated. It's what happened is that they flipped them around because we usually have we usually have dy over dx, but this time we have dx over dy. Okay.
Okay.
So now basically what this is saying is now I have d sine. Oh, sorry, I don't know my s like that. D sine xy over dy. Remember how we had here like d sine x 8x over dx? Here it's the same thing except now it's dy. Do you see the difference?
Yes.
Times d dy of xy. Why I said that was, remember here I did d dx of 8x. So here's the same thing. It's d, but this time it's dy, right? Because we're doing in terms of y, of xy.
So Nora, so we wrote that twice. So right here, we know the first equation is sine in parentheses xy, and then right next to the right, we don't see nothing. The next one would just be is in brackets prime is x and y, and that's how you combined it.
Yes, I don't know if do you guys do the prime? Honestly, I've seen some classes where they do prime. So they say that this is cosine xy, obviously, right? Because like this guy translates into cosine. And then this one, they factor it. They're like, okay, so this is a product rule right here because you have x and y. So you have x. It's gonna be, well, yeah. So it's gonna be x times the derivative of y is just 1 plus x prime, right? Or actually just x prime without the x prime times y. So it's the same thing. Because look what we ended up with. X, this is just the x, but again, don't freak out about this small y. You can erase it whenever you want. It doesn't really matter. This is not like an actual, it doesn't affect your problem. And then this is dx, or this is x prime. This is just another way of writing x prime times y. So here we ended up with the same thing, x, and then x prime times y.
So, okay, so the first one,
There's a reason to it, by the way, if you want to see it. Here's the reason. So basically, let's say I'm doing d x over dy, or actually, yeah, d over dy of some number x, of some variable x. So, okay, like I can't take the derivative with respect to y because they're not the same variable, right? On the bottom and on the top. So what I do is I can multiply this thing by dx over dx, because it's like I'm multiplying by 1. Like imagine it as if it's 1, right?
right?
But I know that dx over dx, right, is equal. Actually, because it's all the same numbers, it's gonna get kind of confusing. Let's say I have here. Let's add a 5. Let's spice it up, okay? If I add a 5, then I can look at this thing. I'm like, I can't take the derivative of 5x with respect to y because there is no y, right? But what I can do is I can look at this portion right here. So I'm like, oh, okay, I think I know what this is. Like, I can be like, oh, okay, sorry, I don't know what I'm drawing. 5x. I'm like, oh, okay, that makes sense. But then what am I left with? I'm left with these. Oh, my battery is running low. I'll go get the charger. But then this one, it goes like this, right? And then so I multiply by whatever I have left, dx over dy, right? And
Right.
so, huh?
Right.
Do you see? Yeah, okay. So you see it, good job. And then it's only the dx and the dx. What is the derivative of 5x? If I just have 5x, what is the derivative of that?
It's just 5.
Exactly. So it's going to be 5 times dx over dy. Because this still stays the same. These go away. Imagine it like that. That's not how it actually happens, but like imagine it like that. It makes it a lot easier for it makes it easier for a lot of people. Okay, so this is why this stays as x prime. Because it's really this dy it's really that dx dy that nobody really like cared about in the beginning. That is like left. It's that dx dy right here. But we don't have 5, we just have 1. So that's why it didn't show as much.
So okay, so f.
But yeah,
So
this is not like this is something else. Oh, there we go. Do you want to try another one? We can do another one if you want.
And then for right here, when we put the brackets.
I wish I could give you control. I want to see what you mean by like. Do you want to do a whiteboard? I think you can turn on whiteboard, and you can like show me what you want. Like write it down. Do you want to share your screen and write it down? Like write down what you mean.
Okay.
Yeah.
to show you on the piece of paper, right?
Sounds good.
Yeah, okay.
It's really up to you if you want to use your iPad, if you want to use whatever.
Let's see.
Hey, I'm gonna go get my charger real quick. My laptop is about to die. My
No
iPad is.
problem. No.
Yeah. Just whenever you're ready, share your screen with me, okay?
Okay.
Yeah. I'm gonna stop the recording for now. We're gonna start another one later.
Okay.